Hello everyone. Okay, so this is going to be the third test in exercise physiology. And I'm making this video short notice, obviously, and I realized for the people who did buy my study guide that it doesn't answer 100% of all the questions because, of course, they decide to teach completely different. And that makes sense because it's different TAs, but again, it's completely different material. It's not even really exercise physiology. Some of the material I don't think is really in the subject of physiology. But, and of course, his study guide doesn't even follow the PowerPoints, which I'm guessing he went over some stuff in class that I wasn't here for, but a few of the questions I wasn't able to answer, like one about low intensity exercise, which we'll get to, but I wasn't able to answer it. But again, I'll explain everything on this as best as I can. Okay, so following the first question, actual it's relative to real life, so you can relate it to your actual training, and you can actually use these concepts in the very first few sections to make your training and how you can adapt to training and all that good stuff. So the first question is just explain the concept of what VO2 max is, what VO2 max measures, how do you determine if the subject has reached it, and how do you clearly use this information. Now, VO2 max is one of the most important, really white shirt. So VO2 max is one of the most important concepts in medical literature. Whenever it's used in hospitals, whenever anyone wants to know the fitness of someone after they have, like, say, a heart attack or they have a heart condition or anything, if a physician or a health professional ever wants to know the fitness of someone, they look at this number. This number is very, very important to determine the health of your heart and thus usually the health of you. So like if someone has a very low VO2 max, like 10, which is ridiculously low, but if someone does have a VO2 max of 10, then their prognosis is probably only 2 to 5 years. It's not, the prognosis isn't that good. Because if you have a VO2 max of 10, you've had a recent heart attack, you have a very, or you're in the ICU, you're just not in good shape. So VO2 max is used extensively to tell how in shape someone is. And what this number is VO2 max is essentially, it's measured in milliliters per kilogram per minute, and it's how much oxygen your body, if you remember from the second test, it's how much oxygen your body can actually use. Whereas the higher the number is, the more oxygen your body can utilize. Lower the number, the less oxygen your body can utilize. Everyone breathes in the same amount of oxygen with every single breath, unless you have a lung condition. But your body only uses a certain amount of oxygen, and this number, VO2 max, determines how much oxygen it uses in milliliters times your body weight per minute. So every single minute you use this many milliliters of oxygen. The lower it is, obviously, the less oxygen you use, the less, that's not good for your body. Because oxygen is important. So that's what it measures. And how do you determine if a subject has reached it? Now, at this point, you've probably done a VO2 max test. You run your ass off on a treadmill until you pass out or until you want to stop. And they put this little tube thing in your mouth, and you can't talk, and it's very uncomfortable. This measures your VO2 max because VO2 max is how much oxygen you use per minute. And it's really hard to measure how much oxygen you use per minute. So they do this by how much carbon dioxide you exhale. And they can only measure how much carbon dioxide you exhale by measuring it through a tube, going into a computer and whatnot. So that's how they do a VO2 max test. Maximum test, you run on a treadmill, they increase the incline every certain increment of stages, usually every 2-minute stages or 1-minute stages, whatever. And then you run until you can't run anymore. And that usually is your VO2 max. But in order to determine if a subject has really reached the VO2 max, there's no way around it. The easiest way is they pass out. Or that's the easiest way, because everyone knows, of course, you can push a lot more than you voluntarily want to. So if a subject stops because they're uncomfortable, most likely they have not reached the VO2 max. They just stopped because they were uncomfortable. This isn't considered the true VO2. This is considered the peak VO2. And that's going to be one of the questions probably. What is the difference between a peak VO2 and a true VO2? A peak VO2 is just when a subject decides to stop. Because we all know you can always go a lot more than you voluntarily want to. So that's why the only real true test is if you pass out. Because if you pass out, that's your body telling itself, calm the fuck down, stop, and you just pass out. It's a safety mechanism. So that's one way, is if you pass out. But no one really is going to do that unless they're crazy or if they're an elite athlete. Another way is if their VO2 stops increasing as the attester increases the intensity of the workload or increases the incline. Since VO2 is how much oxygen used per minute in milliliters, common sense will tell you that the harder you're working, the more oxygen your body is going to use, the more this number will increase, and that's what happens. That's why they increase the intensity, because the harder your body works, the more it's stressed, the more oxygen you use. Now, if you continue to increase the workload and your VO2 max does not increase anymore, that number stays constant, then you've reached your VO2. And now at this point, you're just relying strictly on glycolysis and all that aerobic rep, and you're probably going to be stopping within the next 2 minutes or so, or 30 seconds. You're just kind of like the finishing catch. Yeah. Shirt's not as bright, shining. So that's two ways. You pass out, or your VO2 max stops increasing with increasing workload. That's usually the most common one. Most people do not pass out. The VO2 just stops increasing with the workload. Another one is if the RER or REQ, same thing, respiratory exchange ratio, reaches above 1.1. That will be on the test. He's probably going to ask a multiple choice question, and it's probably going to be like 2 of the above, all of the above, or something. So if your RER is above 1.1, then you're considered to reach your VO2. The reason is because if your RER, as you recall from the first test, if your RER is 1, that means you're burning carbohydrates. If your RER is higher than 1, then you're burning, I don't really know how to say it, but you're pretty much in a complete lactic acid, you're about to pass out, you're at your max. That's just higher. You're burning a lot more, or I don't know, your body's at its max. So there's 3 ways. Another way that's not really used a lot, but you have to know it, is if your heart rate, because they also record your heart rate on a VO2 test, is within plus or minus 10 beats of its estimated max, which is 220 minus your age, then that's considered you're at your VO2 max. Now that's not really used a lot, just because you can tell 220 minus your age is just an estimate, it's not really accurate. So say mine was 190, well estimated, which is 199, so we'll go with 220 minus 23, 197. So we'll go with that. So if my heart rate is at 187, what this is saying is I reached my VO2 max, and that's definitely not true. So that, again, that's another protocol, so just have to know those protocols. Plus or minus 10 within your age, you pass out, your heart rate stops increasing with your VO2 stops increasing with increased workload, which is the most common one, or your RER is above 1.1. And I can guarantee you he'll ask this question, and it'll be a multiple choice, and the answer will probably be 2 of the above or all of the above. Okay, and how it can be used. This number is very important. Oh, the last one I forgot, because it's not really too common. If your blood lactic is measured between 8 and 10 millimoles, the more lactic you have in your blood, the more you're relying on glycolysis. So this isn't really true. Also, I've seen people who have lactate of 12 and they're not at their VO2 max. So, but that also is a criteria. And again, this is used because this is a very important number. This number is, you can pretty much tell someone's fitness by looking at this number. So you can determine the exercise prescription, determine the plan of care if you're a health professional. And number 2 is what are some factors that can affect VO2. Now, VO2 is how much, as we know, how much oxygen your body uses with every breath or every minute. We'll say it, how much oxygen it absorbs. So this tells you right now the factors that affect it is having more enzymes that absorb oxygen. So more oxidative enzymes can easily increase this number, and that's one thing that occurs is oxidative enzymes. And I guess he's asking what tests or what activities yield the greatest VO2. Of course, running, because since VO2 is how much oxygen you use per minute, running you use the most muscles. So the more muscles you use, the more oxygen you need. So that's the best test, is running. Amount of mitochondria, as we know, mitochondria produces energy. So the more mitochondria you have, the more energy you produce. The more energy you produce, the more oxygen you need, and more mitochondria runs on oxygen, aerobic glycolysis, oxygen, good. Aerobic oxidation, sorry. Hereditary, identical versus fraternal. I can't really talk too much on that because that's not really a new topic, but it's a topic people don't talk about a lot, about hereditary and fraternal. I see someone already asked that on the Facebook group, so just go with what they said. Gender, males will always have a hot, well not always, but if a male and a female are in the same fitness level, same shape, that same magic threshold, everything, then a male will always have a higher VO2, simply because men have more muscle and they have more hemoglobin. Since VO2 is made of oxygen, more hemoglobin means you can produce more oxygen. More muscle mass means you use more oxygen. So males will always have a higher VO2. And that's not to say all males have less higher VO2s than women. If you take an elite woman athlete, she most likely will have a higher VO2 than a sedentary male. Not too much higher, but I think of women's, the highest that's ever been recorded was like 60, which really isn't that high for a man. So they have less muscle mass and less hemoglobin. So that's the reason why. Training increases your VO2, as we know, but only at most from 20%, because it's mostly hereditary, and training can increase it a lot, but there's a certain level you'll get to where you can't really increase your VO2 anymore. Again, mostly inherited. Age will infect it. I don't know if he talked about that. Of course, that's common sense. The older you get, the more efficient you get using oxygen. We get more muscle, we get better. Up to around age 25, then your VO2 starts decreasing. Just because the older you get, the less efficient your body, you're not in shape as much anymore. Of course, you can be in much better shape with age, but that's a general term. So once you hit 25, your VO2 starts decreasing. Three, what are some factors responsible for improving VO2? Include the cardiovascular changes you expect to see with exercise training. Well, you can just break it down to the formula. VO2 equals cardiac output times atrial venous return. You can't really increase your atrial venous return with training. I mean, it is what it is. You don't get in better shape with that. But cardiac output does increase substantially with training. And you can push this all back to the second test. Cardiac output is heart rate times stroke volume. Heart rate doesn't really increase with training, but stroke volume increases substantially. Just take all the factors that increase stroke volume. Just take all the factors that increase stroke volume, and take this text message, but just take all the factors that increase stroke volume, and that's how VO2 increases. Your body gets more efficient at pumping blood with every beat, and it does this by making more oxidative enzymes. So I just say pretty much, yeah, the Frank-Starling mechanism. The most important one the word that he's going to want to know is atrial venous return. I mean, not atrial venous return, venous return. Your body gets more important. Your body gets better at pumping in venous return, pumping blood back to your heart. So venous return is really the answer I believe he's looking for. And the cardiovascular adaptations are all gone over the second test. That's just, again, Frank-Starling mechanism. You increase your end-diastolic volume, increase your stroke volume, increase your venous return. All these things will increase your VO2. Because the more blood you pump, the more oxygen you'll probably use from that blood. Now, the most important thing about VO2 is it affects your recovery time. If your body is really efficient at using oxygen, you will recover much faster because you have a lot more oxygen with every breath or every minute. So as one's aerobic fitness increases, as the VO2 increases, they're much better at recovering, which that can be seen by, take elite athletes, have them exercise, they're probably not going to get tired because the body is so well at recovering, they're so efficient at using oxygen. 4, how does the concept of specificity apply to talking about VO2? Include the mode of exercise, subject fitness, and describe different types of equipment that one might use to measure VO2. Well, the best VO2 is a treadmill test. I'm sure that's going to be a question. Treadmill test produces the best indication of VO2 because it uses the most muscle mass. So you take a sedentary individual, you want to get them on a treadmill test to get the VO2. You wouldn't put them on a cyclogometer. A cyclogometer for VO2 is really only used if someone prefers to use a cyclogometer because they're a cyclist, but mostly a treadmill will yield the most accurate result because it uses the most muscle. Yes, I don't know if he talked about maximal test, which is on a treadmill, running your ass off, passing out, you have tubes in your mouth, uncomfortable, or a submax test, which is on the cyclogometer. And a submax test is just an estimate of your VO2 because you don't exercise to your maximum, you just exercise to your submax level, and they can estimate your VO2 from that. And the step test, I don't know if he talked about, but there's also a step test, which isn't really too accurate because it's stepping. What factors account for gender differences in VO2? I'm sure this will be a question. It was when I took the class. Gender differences, men will have a higher VO2 simply because they have more muscle mass, they have more hemoglobin, not because men are better at fitness than women, just they have more muscle mass. It's a fact of life. Women would really never, it's just not possible, women would never surpass a man in VO2 in the same fitness level. Again, the highest a woman's ever recorded was probably around 65. Highest a man's ever recorded was 95. 70 is the normal for a man, elite athlete or cross-country runner is 70. So it's simply because women are smaller, they have less muscle and less hemoglobin. Now, so the next chapter is on training principles. Now, this is the concepts that you can take and put into your own training, and you can realize, oh, that's how you improve. That's how your body improves and gets better. So the first question is, be familiar with factors that affect aerobic training response. These, I'm sure everyone knows, everyone who's ever worked out knows these factors. These are the things you play with in every single exercise set. You have your repetition, or I guess I'm not talking about weightlifting anymore. We have frequency, which is like repetition, how much you work out per week or how much you exercise, we'll take running, how much you run per week, so frequency. Duration, how long you run. Intensity, how intense you run. So frequency, duration, intensity. I think time is the same thing as duration. Duration, frequency, intensity, those are the most important ones. Mode isn't really too important. It's just type of exercise, running, swimming, biking. But the most important ones are frequency, duration, and intensity. Intensity is the most important one, as you'll find out. Intensity is probably going to be the answer to a lot of things if it involves intensity of exercise versus duration versus frequency, like which one's most important, which one yields the best results. It's intensity. And it's also what I say. Intensity is the most important factor that can be manipulated to achieve training effects. If you work out very intensely for 2 times a week versus just pretty much half-assing it 4 times a week, you're going to get much more benefits by working out intense. It's just the way it is. Your body responds to intense by stressing it, by uncomfortable environments, and that's how it gets better. It doesn't really respond. I mean, it responds to you like half-assing, just getting out there, increasing your heart rate, but it responds a lot better to being intense or in an uncomfortable environment. So intensity is the most important thing. And an example, with frequency, you need at least 2 days to receive any benefits. That's with frequency. That's the cutoff. But intensity is the most important thing. Maintenance of aerobic gains. Again, that goes back to intensity. You can maintain your aerobic fitness by being intense, by having, like, say you're extremely busy for some reason and you're a cross-country runner. That's a bad example, but say you're extremely busy and you run 4 times a week. You don't have time to run 4 times a week, so what you could do is you can just have a really intense interval training 1 time a week and still maintain the same fitness. Because intensity is a lot more important than anything else. Understanding cardiovascular adaptations that occur with chronic training. Most of these were answered on the second study guide about how the heart adapts to training, increases the stroke volume, your heart rate, your heart responds to it, gets stronger, so it doesn't have to work as much, so your heart rate gets lower at the same intensity. Your stroke volume increases, your cardiac output increases, as you know now, your VO2 increases, Starling mechanism, all that good stuff. See what I said, blah, blah, blah. Your heart rate at rest will become lower, thus we talk about parasympathetic activity, so at rest you have a much lower heart rate, your heart doesn't have to work as much at rest. Via vagus nerve, the acid again. Higher stroke volume, your heart's much more efficient at pumping out blood with every single beat. And you have a higher stroke volume because of Starling's mechanism. In diastolic volume, your heart just holds more blood, you cycle more blood, increased venous return, that's a very important word, increased venous return. Okay, damn it. Question 4, explain the concepts of overload, reversibility, where they apply to training, understand, and blah, 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 the different ways you can affect overload. Overload is the main concept it's the main point of any exercise, aerobic exercise or resistance. In this case, we're talking about resistance, because overload is much easier to see in resistance exercise. Overload means, your muscles can lift a certain load. Overload simply means overloading the muscles. So applying more stress than they can handle, so you overload the muscle. This is the point of working out. So you overload your muscle, and by overloading the muscle, you cause it to literally break down. So if you look at a sarcomere, which is the muscle units under a microscope, they're literally fucked up, they're destroyed, the actin and myosin are all messed up, and the proteins are destroyed. You have all this lactic acid, you have waste products. Can't really think of any right now, like nitric oxide. You have a bunch of waste products in your muscles after you work out. It's kind of like havoc, like chaos. Like once a tornado crosses a prairie field or whatever, or take a house. If a tornado crosses a house and the tornado fucks up the house, that's literally what your muscle looks like after you work out. It's just complete chaos. You destroyed it. But this is good because this was the point of working out. So now your muscles rebuild a lot stronger, and it kind of like fortifies. That's one word for it. Fortifies the. In this case, go back to the house. The tornado comes by, fucks up the house. And now, like your muscles fortify, rebuild the house, so it's much stronger. So next tornado comes through, it might not fuck up as much. So it fortifies and makes the muscle stronger. So that's the point of overloading the muscle. And thus this also means if you don't adequately overload the muscle when you work out, you're really not going to achieve training benefits. Your muscles only adapt to stress. It has to be the right amount of stress. Enough stress to break it down and challenge your body. And challenge the environment. Your muscles adapt to the environment. So if you're just working out like curling 20 pounds and you can easily curl 20 pounds, you didn't get any training benefits because your muscle was not challenged, it wasn't stressed adequately, it wasn't overloaded. So you didn't destroy anything, pretty much you didn't get any training effects. So that's what overload means. Reversibility, everyone knows that. Reversibility means you gain training benefits, you stop working out, you're going to lose those training benefits. Muscle does not turn to fat, it's a complete myth. But your muscles do get smaller because, again, muscles adapt to stress. If you're not stressing your muscles, they're not going to adapt to it. They're going to adapt to exactly that. They're going to adapt to nothing. They're going to adapt to not working out, so thus they'll get smaller. They have no reason to stay big if you're not stressing them or working them out. What is the Carbonin formula? You might have to calculate that. What is optimal target heart rate for cardiovascular adaptation? Use the Carbonin formula. Carbonin formula is if you're writing an exercise prescription for an individual, a legit exercise prescription in a healthcare setting, you have to use intensities. And that's also the easiest way to get trained is through heart rate intensities. And to find these intensities, all you do is take their age predicted max heart rate, so 220 minus their age, whatever it is, and then you get that number. That's their age predicted max heart rate, and then you multiply it by the intensity you're trying to find. So let's say you're trying to find 50% of the max VO2, 50% of the max heart rate. In my case, you would take 197, 220 minus 23, 197 times 0.6, convert the percent to a decimal, times 0.6, and there you go, whatever that number is, and that's 50% of my max heart rate. Now, very rarely is he going to ask you for, or in a clinical condition, or is you going to have to find just one percentage. It's going to be usually a range of percentages and say, here, exercise at this range of your max heart rate and you get training benefits. Not exercise at exactly 50% of your max heart rate because that's one number. It's very hard to exercise at exactly one number. So you say between 50 and 60%. You would do 197 times 0.5 to get whatever number that is, and 197 times 0.6, and that's your range, and you want someone to stay in this range. And again, everyone knows what this is. You go to the gym. I'm sure everyone's experienced this, but you go to a gym, an elliptical, whatever the hell, wasting time on an elliptical. But you go to elliptical, and you look at the little pictures, and they say, "Oh, this is your heart training, your fat burning zone," and it's like 1/6. It's like certain percentages. And by the way, fat burning zone is a myth, also. So I'll go over that when we get to one of the questions that ask about that. I don't know. Task specificity is task specific. Very simple. It means muscles only get better at the task you offer them. If you're running, you get better at running. You don't get better when you get better at cycling to a point. But if you're an elite runner, you're going to be really good at running, obviously. But that doesn't necessarily mean you're an elite cyclist. It doesn't transfer that way. It transfers to a point, of course. That's the point of triathletes, but it doesn't really transfer the same. Like if you're a really good runner, that does not mean at all you're a good swimmer. That's a pretty good example. Because swimming is a completely different skill set than running. New question, what are the advantages? Ooh, there's a necessarily space right there. What are the advantages of training at lactic threshold? Lactic threshold, of course, we all know when you exercise, your body produces lactic acid. We'll keep it simple and say when you're exercising at max intensity or anaerobic, you're producing a shit ton of lactate. Your body normally recycles this lactate via the Krebs cycle or oxidates it, whatever you want to say. But it recycles it, brings it back to the liver, thus you make more glucose and you're happy. Or you exhale, or you can recycle it into carbon dioxide, exhale it, whatever you want to do, whatever you want to say. But that's not important. The focus here is what is lactic threshold. Now, our body has a certain threshold that it can recycle this lactic, or it can oxidize it, and it only has a certain ratio number. So let's say it can only oxidize 5 molecules of lactic acid every second. So it's perfectly fine. So say if you're making 4 molecules of lactic acid a second, it's perfectly fine because you can oxidize that. It's less than your lactic threshold. But let's say you start producing 10 moles of lactic acid per second. Well, you can only oxidize 5 of that. So that means it's above your threshold. So at this point, you're going to be accumulating a lot of lactic acid because you can't get rid of all that lactic acid. You can't clear it. Just like taking out the trash, it's perfectly fine, but the trash starts overfilling. It's past the trash threshold, if you want to say. And at this point, you can't keep up with the trash going up because you can't. It's filled. So it's kind of the same concept. This is a lactic threshold. Now, the advantages of training at lactic threshold is just like anything in the body adapts. So if you're trained at exactly your lactic threshold, which is a certain percentage of VO2, but if you're trained at exactly your lactic threshold, your body gets better and recycling lactic acid. If your body's better at recycling lactic acid, as we know, lactic acid is what raises the acidity in your body and kind of stops muscle contraction and kind of is what causes you to stop exercising and causes the burning sensation in your muscles. Well, if you have a higher lactic threshold, you can endure much more lactic acid before it starts overwhelming your body. So a higher lactic threshold is much better for you. So this is the benefits of training at lactic threshold. You get much better at recycling lactic acid. The better you're at recycling it, the more you can exercise. And then the last thing is, I believe the last example he tries to give you is take 2 people at the similar VO2. So say the VO2 is 80 milliliters per kilogram per minute, which is extremely high. But probably elite athletes, elite runners. So you take both of them with the highest VO2s and they go run. They do a 5K or a mile. Well, who's going to win? It's not as simple as just looking at VO2 numbers. If you can do that, every single race will be running in a laboratory and just say, oh, my VO2 is higher than you, so I can beat you in this race. That's not really true. It's true up to an extent, but if you take 2 athletes with like 80 VO2, 80 VO2, or 80 VO2, 78 VO2, whatever, it's extremely close. What determines which one actually wins is, of course, how much they want to win and their mentality, but also the lactic threshold. If we take similar VO2s, they'll take the guy with the 80 VO2 versus 78 VO2. The guy with the higher VO2, but he has a lower lactic threshold. His lactic threshold is only, say, 7 millimoles. Now the guy with the 78 VO2, say his lactic threshold is 11 millimoles, much higher. Well, the lactic threshold guy will, at the same intensity of exercise, this dude will be producing much more lactic acid because it's across his threshold than this guy on the same intensity, but it's not across his threshold anymore, so he can clear the lactic acid he is producing. Well, this guy is obviously in much better shape because he's not working as much. He doesn't have as much lactic acid in his body as this guy, so he'll beat the 80 VO2 guy. So it's not VO2 is not the final indicator. Lactic threshold is very important also. Okay, now this is question 8. Talks about interval training, and I'll also go over why the fat burning zone is a myth. It doesn't really exist. What is interval training and what is its rationale for its use? Interval training, I'm sure we've all done it, is you run a set number of repetitions and a set intensity with a set rest period. So say, again, we'll go back to running because I'm a runner. So say you run 6 400s, or 1 lap on the track. So 6 400s at 60 seconds of 400 with 1 minute rest between. That's interval training. Or another instance I gave was 12 200s at certain pace, 30 seconds with 1 minute rest, or 30-second rest between. That's all interval training. Interval training can be anything as long as it's in, what the word says is in intervals. Training is the best method to increase lactic threshold. Lactic threshold is a certain number, just like your Vo2 max. It's a certain percentage of your Vo2 max. I don't really know what percentage of it is. And it's one of the best training to increase your lactic threshold, which is why all cross-country runners, all track runners in a legit program do interval training, because this is how you increase your lactic threshold in your VO2 max. You don't really increase your VO2 max by doing cardio, long duration cardio. You increase your VO2 max by stressing it during interval training. Okay, and of course, another very positive use is that it's the best type of training to lose fat loss or fat. And then I believe at this point, I don't know if he talked about this, but this is me talking now about training, just so you can know for training, so you can actually use this benefit. But interval training is one of the best ways to lose fat. So if you want to lose fat, do not go to the gym, go on the elliptical treadmill and work out for 40 minutes. Because one, that's incredibly boring, being on a treadmill or stair stepper or whatever the hell for 40 minutes, and it's just not effective at all. And who has 40 minutes to spend running in place? No one really. So you can maximize your time. You can burn much more fat by doing interval training. And what it is it takes advantage of that system that we talked about in the first test called the excess post-oxygen consumption, or EPOC, by taking advantage of oxygen debt and oxygen deficiency. And of course it does this because when you start exercising, you're in a deficiency of oxygen, so you have to kind of build up to the oxygen, you're panting, all that stuff, which this is why interval training is, because it's so intense, your body's not ready for it. But when you stop exercising, you're in oxygen debt, and at this point, your metabolism is elevated for the next probably up to 6 hours. And at this point, in the long run, you burn many more calories than you do by being on a treadmill for 40 minutes. Plus, it doesn't take as long. It only takes 10 minutes. I can get a really good workout in 10 minutes and burn much more fat in the long run than someone can on a treadmill that stays on a treadmill for an hour. Plus, it's much more enjoyable and fun. And the way I do this is, it's a form of interval training. I go out, I sprint 15 seconds, jog 60 seconds, repeat 10 times. That's interval training. You have your time, you have your intensity, and you have your rest period. And this only takes 10 minutes, and I burn many more calories than someone would by being on a treadmill for 40 minutes. By oxygen debt, by increasing your metabolism after exercise. Now, if someone wears a heart rate monitor during interval training and it tells them how many calories they burn, they'll see that during the actual training part where they're running, they're only burning, say, 50 calories. But all the benefits come after you stop exercising, which you can't really measure with a heart rate monitor. It just happens by oxygen debt. So that's why interval training and high intensity is much better at burning weight. And I'm sure everyone's heard about that. It's called high intensity interval training, HIIT, HITT. That's what insanity is based on. That's why insanity works, because it's actually based on real science. Okay, so that's everything about aerobic activity. So again, intensity is the most important thing. What else did we talk about? Overloading the muscles, reversibility. That's very simple to know. I'm sure everyone knows what that means. Okay, so now we'll go to the endocrine response to exercise. Now this section changes on every class, because Eddie taught it for the past semesters, and Eddie included different questions, and now different TAs taught it, and a lot of them are the same questions, but again, they started talking about fluid regulation and all these hormones and the endocrine system and whatnot, so it's different. The question 1 is, know the 3 ways that catecholamines and glucagon regulate blood sugar. But the catecholamines are epinephrine and norepinephrine. It's just another fancy word for epinephrine and norepinephrine. And the glucagon is the enzyme that our insulin. Glucagon is the enzyme that our kidney. Glucagon is the enzyme that our pancreas releases to increase our blood sugar. So as we know, we increase our blood sugar, we release insulin. Insulin will cause that blood sugar to go into the cells, so we can use that sugar, like glucose, for gluconeogenesis, glycogenolysis to make new more glycogen, or glycolysis to actually break down the glucose for energy. Now, glucagon is when your blood sugar gets low enough, which everyone's experiences when you're hungry. That's what happens. Your blood sugar gets low enough, your pancreas senses this and releases glucagon, and glucagon will increase your blood glucose. And it will do this by any mechanism. By gluconeogenesis, by creating more new glucose out of not glucose molecules, by taking protein, fats, amino acids, lactic acid, whatever, to make glucose. That's gluconeogenesis. You increase your blood sugar. Or glycogenolysis, breaking down glycogen, because glycogen is a storage form of glucose, so you have this massive amount of glucose in its storage form, breaking off that glycogen, and thus you increase your glucose. Now, how are the catecholamines affected? Essentially, you can kind of see this concept. Epinephrine is known as adrenaline, and it makes you more efficient at exercising, increases your heart rate. Well, how does it do this? You just gotta think, what will cause you to exercise longer? By increasing your fuel use, right? And your fuel is glucose. So epinephrine increases glucose levels just like glycogen. It causes glycogenolysis, so it causes glycogen to break down to glucose by increasing your blood glucose, and thus you have more glucose to burn for energy. So that's how epinephrine really works. Of course, it increases your heart rate and whatnot, but it causes glycogenolysis, so you have more blood glucose to burn to ATP. Two, describe how catecholamines affect fat mobilization in cells with respect to different androgenic receptors, beta versus alpha receptors. Now, this is confusing because he had the PowerPoints. You have the endocrine PowerPoint 1 and endocrine PowerPoint 2, yet this question is not talked about at all in any of the slides, but it was talked about in Eddie's slides, which is kind of weird. So, yeah, he asked it on his study guide, so I don't know if he talked about it in class or whatever that guy's name is, Chris talked about it in class, but it wasn't on his slides. But what it is essentially, the catecholamines combine to two different types of receptors, beta receptors and alpha receptors. And in my notes, I have that beta receptors cause lipogenesis or lipolysis. Lipolysis is the breakdown of lipids, so lipolysis is good in this sense. Well, it's always good if you're breaking down fat and burning it. So whenever epinephrine binds to beta receptors, it causes lipolysis and use fat for energy. So we want it to bind to beta receptors. When it binds to alpha-2 receptors, that's different. You kind of inhibit fat breakdown. And I know for sure one of the questions on our test was they use the word HPL. HPL is an abbreviation for hormone-sensitive lipase. Hormone-sensitive lipase breaks down by its name, lipase, hormone-sensitive. It's sensitive to hormones, and it breaks down lipids. Or it's an enzyme that breaks lipids. So hormone-sensitive lipase breaks down lipids. And this is how epinephrine works. And you can see that maybe since alpha-2 inhibits lipolysis, maybe fat people have a lot, heavyweight people that have problems losing weight or obesity have a lot of alpha-2 receptors. And that's one of the hypotheses that maybe obesity have a lot of alpha-2 receptors because alpha-2 receptors inhibits fat loss. The beta receptors are the good ones that cause lipolysis. Question 3, describe the effects of the glycemic index on exercise performance and recovery and understand the mechanisms of the glycemic index. Now this question will probably be on the test. The glycemic index is a number that tells you roughly, will it be a high or low number? High number, it tells you roughly how fast your body absorbs the glucose that it just ingested, because glucose isn't everywhere, you can't get around it. But the number that this glycemic index is how fast your body actually absorbs it. With a high number being your body absorbs it extremely fast, and a low number meaning your body absorbs it slow. Now, both of them can be good in most cases, not most cases, but high glycemic index is usually bad. That's like processed foods, sugar, candy, potato chips, junk. Normally that stuff has high glycemic index. The reason is because your body, it has a lot of glucose, but it gets into your body and your blood, and it's chilling in your blood. But since it has such a high glycemic index, your body absorbs it extremely fast. So maybe say within an hour, or not an hour, maybe within 30 minutes, it's all into your blood. I mean, it's all entered your muscles or your organs. So your body's absorbed it extremely fast. And the reason this is bad is because it absorbs it extremely fast, but your body does not really adapt to it and catch up. And your body and all of a sudden, well, I guess we'll go into the real physiological sense. I don't know if we quite test on it, but all this, so you have this massive amount of glucose from eating a candy bar, whatever, a high glycemic index. Your body's, it's a high glycemic index, so it's absorbed extremely fast. So your body releases a shit ton of insulin, more insulin than you actually need to absorb the food at a decent rate, or absorb the blood sugar at a decent rate. So you absorb all this glucose, this blood sugar, extremely fast. Now you absorb it extremely fast, but you had so much insulin that your body does not, your brain doesn't catch up to the fact that all that glucose went into your cells. So your brain senses that you have low blood sugar and senses that you're hungry. And thus, since you're hungry, when you're hungry, you want to eat more. It drives you to eat. So what do? You eat more. So this is this is how eating candy bars, high glycemic index foods, potato chips. This is how it leads to obesity a lot more. It's not the carbohydrates. It's the fact that it's a high glycemic index food. You eat a lot. It all goes into your cells. Your body thinks it's hungry, so what do? You eat more, but it's really not hungry because you had all that sugar inside your cells already. So you kind of like trick your body. So you're on a vicious cycle. Low glycemic means your body absorbs it really slow. That's like oatmeal, steel cut oats is the best example. So your body absorbs the glucose very slowly. So over a period of like 4 hours, your body's still absorbing glucose. So thus you're, maybe not 4 hours, but you stay satisfied for 2 to 3 hours because your body, it's a low glycemic index food. Now, how this relates to exercise performance, if you have a high glycemic index food right before exercise, that's not too good. You can tell because you ingest all this glucose into your blood, but your body absorbs it extremely fast. So say you have a candy bar right before you exercise. So you have all this blood sugar. It does have a lot of carbohydrates, but you absorb them extremely fast. So say 10 minutes after you exercise, maybe you absorbed all those carbohydrates. So now you have a really low blood sugar, and you need sugar in your blood in order to do glycolysis and all that good stuff to get energy. Well, it's not in your blood anymore because it's a high glycemic index food, so thus you crash. Low glycemic index foods is, since the glucose is absorbed much slower in a steady stream, you have glucose in your blood a lot longer. So that's why it's always best to eat have oatmeal before you exercise, have a low glycemic index food, have a granola bar with low glycemic index, whatever, because you have energy available much longer. Now, the opposite is true when you stop exercising. When you stop exercising, as we know, when you stop exercising, your muscles are extremely hungry. They're craving glucose. They're craving energy. So you want to get glucose to your muscles as fast as possible. Now, a low glycemic index, since it's absorbed very slowly, is not really the best choice to getting glucose to your muscles. So you want to have a high glycemic index food. So that doesn't mean go have a candy bar once you're done exercising, but you want something with a high glycemic index, so in order to absorb that glucose much faster. And they say you have I said shot in my study guide apparently, but they say they have a short window. They say the window is 0 to 2 hours. The window is not really that big, not 0 to 2 hours. In every single class you take, the window's lower. I think he said the window is like 0 to 30 minutes. Oh, that's what I said from personal experience. But essentially you want to have glucose after you're done exercising as fast as possible. There's really just as fast as possible after you exercise you want to eat. Even if you're not hungry, eat after you're done exercising. So for people who go to the gym, work out, weight lift, eat once you're done lifting or working out. Do not work out and then don't wait like 2 hours to eat and be like, oh, I'm starving myself, so I'm burning more energy. No, you're not. You're starving your muscles, and thus they're not growing. They're not getting the benefits of working out because you didn't feed them with anything. So eat as soon as you're done exercising. For describe the effects of cortisol during exercise with respect to glycogen levels and how cortisol regulates glucose levels. Cortisol is known as the stress hormone. So as your body is stressed, you release cortisol. Now in this instance, they're referring to stress in the positive sense, so stress is exercise. So say you're exercising, and which it is because you're stressing your body, it's not used to it. So say you're exercising, and after like 30 minutes or 40, well, an hour is usually the cutoff, but say after an hour, then you start releasing cortisol. You release cortisol because you're stressing your body, because an hour is a long time to be working out, so you're stressing your body, and you release cortisol. Now, you can kind of guess what cortisol is going to do. If your body is stressed and you're releasing cortisol while you're exercising, what do you think it's going to do? It's responding to the stress, so you make more energy. So cortisol is known as an anabolic hormone, okay, we'll just cross that out because I don't think it's ever referred to anything. But cortisol essentially increases blood sugar. So cortisol is going to do anything it can to increase blood sugar through gluconeogenesis, glycogenol, and glycogenolysis. But also, it will increase fat breakdown, lipolysis. Cross that off again. It will increase protein breakdown. That's the major thing about cortisol. You don't really want to release cortisol because it'll increase protein breakdown. Because proteins can be used to form glucose through gluconeogenesis, so you will increase protein degradation or protein breakdown. And cortisol is released by the adrenal cortex, like right above your kidney. So it'll increase glucose in the bloodstream through any mechanism it can to get glucose. Mostly by break down glycogen, but at this point you probably don't have any glycogen, that's why you're releasing cortisol and you're so stressed, so you're probably breaking down proteins, so it's not really too good. And the last thing I said is that's why people say stress is bad and it makes you fat, and it actually does, because when you're stressed, you release cortisol, because it's a stress hormone. Your body doesn't know you're not exercising, it just responds to the fact that you're stressed, even though it's a different kind of stress. So you're stressed, so you release cortisol. Well, your body's like in survival mode, and it does what cortisol does. Cortisol does its job. It increases blood glucose by gluconeogenesis and whatnot, by increasing your blood glucose. Well, you don't need blood glucose because you're not stressed. So your body will still increase your blood sugar when you don't even need it. So what happens to excess blood sugar when you're not using it? It turns into fat. And that's how stress actually makes you fat, by increasing your blood sugar. Describe, we talked about that. 5. Understand the mechanism of glucose uptake in muscle cells. This is with insulin. Insulin causes blood sugar to enter your muscle cells. Normally, glucose cannot enter the muscles without insulin. Insulin is what causes this. It does it through the transporter, GLUT4. GLUT4 is the main transporter that it's kind of like the door. Insulin is like the key, if you want to think. And glucose can't get into the cells without the key, glucose can't get into the cells without the key, insulin, but it also can't get into the cells without the door, GLUT4. So think of it like that. I don't know if, okay, yeah, I guess they talked about why exercise. Okay, the reason why you want to eat right after you exercise is because, or right after you run in this case, we're talking about cardiovascular exercise. The reason being because right after you exercise, your body, your cells express more GLUT4 transporters. And these transporters go to the surface of your cells, or they translocate, if you use that word. They translocate to the surface of your cell. Well, once you're done exercising, you have all these GLUT4 transporters, all these doors at the surface of your cell. And now, the thing is, once you're done exercising, you don't really need insulin. Glucose can enter the cells without insulin. Don't know if we talked about that, but glucose can enter the cells after you're done exercising because you have so many GLUT4 transporters. And this is why you want to eat right after you're done exercising, because all these transporters translocated to the surface of the cell. Now, why you have that window is because within 30 minutes or within an hour or whatever, the transporters start going away from the surface of the cell. And at this point, you can't really absorb glucose as readily. So you don't really take advantage of it. So take advantage of that window. That's the point of training, so you can recover. You get stronger during the recovery, not during the actual training. 6, describe the mechanisms through what simple supplements might affect fat metabolism. This is so weird because, again, it's nowhere on the endocrine slides, which it should be, but he asks the question on his study guide. So it's making me think that maybe he just copied and pasted the study guide. I don't know, but again, it's not talked about at all in any of the study guides. But I will talk about it, but it's not on the study guide, on the PowerPoints at all. But the mechanism through which supplements might affect fat metabolism, supplements do cause you to lose weight through certain mechanisms, but they're not really, like if you want to lose weight, you don't take a supplement, you exercise or you eat right. Now, if you go back to also the knowledge that the beta receptors are what causes lipolysis when epinephrine binds to it, and the alpha receptors stop lipolysis. So scientists have used that, or GNCs and marketing have used that science as a selling point by saying, oh, it's a beta-2 beta-2 agonist, which just throwing all these fancy words in there to brain. So one is green tea extract. Green tea extract is natural and inhibits the enzyme that breaks down epinephrine. That's how it works. And if you inhibit an enzyme that breaks down epinephrine, and epinephrine causes fat loss because it's adrenaline, you will lose more weight. That's why green tea extract is beneficial. Caffeine does the same thing kind of. It causes, as we all know, caffeine actually does cause fat loss. That doesn't mean drink a lot of caffeine and you'll lose a lot of weight, but caffeine in moderation does cause fat loss. It does cause you to mobilize fatty acids more. This is how caffeine is actually a performance enhancement. Not because it makes you jittery, but because it causes you to utilize fatty acids more. Yeah, not going to the next ones because that wasn't on a slide at all. Notable: cortisol, catecholamines, glucagon, and growth hormone in prolonged submaximal exercise. Also know how to respond to changes in intensities. But first we're going to go over growth hormone. Growth hormone, it's a hormone that causes growth through protein synthesis, causes your bones to grow more. It's an anabolic hormone, builds tissues, increases fat metabolism, and pretty much anything that is associated with growth hormone does. And it kind of increases, well, what the slide said is it increases with exercise intensity linearly. And this is true. As you exercise more, you release more growth hormone. Now for the catecholamines, epinephrine and norepinephrine. Epinephrine is adrenaline. It's the most common catecholamine. That's the one we really care about. Your body releases mostly epinephrine. Well, his slides kind of have two different points. It says it releases around 80% total epinephrine and 20% total norepinephrine, which is true, but you release more norepinephrine than you do epinephrine, which is kind of confusing, but you release around 80% norepinephrine. Sure. You release around 80% epinephrine. Cortisol, we know, is a stress hormone you release when you're stressed from the adrenal cortex. Glucagon, we already know what glucose is. Now for the exercise intensities, the only slide he had on exercise intensities was that epinephrine isn't produced until around 50% or 75%, number he used. You don't produce epinephrine until around 75% of your max VO2, but you produce norepinephrine up to norepinephrine continues to increase with exercise around 50% of your VO2. Norepinephrine will increase, but epinephrine only increases up to starting at 75%. And again, apologize, but on his PowerPoints, he had no slides talking about intensities of exercise in regards to catecholamine. Well, catecholamines that only slide, but in response to glucagon, growth hormone. 8, we already talked about, understand the mechanism of glucose uptake in muscle cells. As you work out, you produce more glucophoric transporters. They translocate to the surface of the cell, and thus you can absorb more insulin, glucose. Here we go, new stuff. Know the hormones that affect fluid regulation and blood pressure regulation during exercise, with particular attention to angiotensin II, aldosterone, and ADH. Well, the purpose of all these hormones is to increase your fluid balance. Now we'll go back to what happens when you exercise. When you exercise, you sweat. And when you exercise harder, you sweat a lot more. Well, sweat is water, so the more you sweat, the more water you lose, the more dehydrated you get. What else is water? Blood is also water, so the more water you lose, the more your blood volume will decrease, and the more your blood volume decreases, well, as we know, blood is good, so you want more blood during exercise, so the more your blood volume decreases, the more your exercise performance will decrease. So we want to counteract this, remedy this by increasing our fluid level, and blood plasma level, which are kind of the same thing. Of course, you can drink water during exercise, but that only works so well, so you have certain enzymes, ADH and aldosterone, to increase your fluid balance. First one we'll go over is ADH. ADH is released by your posterior pituitary on your brain over here. First, your brain senses that you have low fluid balance, low blood plasma level, so you release ADH in response to that. So what ADH does is it goes all the way down to the kidneys, which is where fluid balance is regulated, and it acts on the collecting ducts, which is like the final tube before the fluid or urine leaves your body. And it tells your collecting ducts or your body to reabsorb as much water as possible. Because you know urine is mostly water, so it tells your body to reabsorb as much water as possible in order to increase your fluid regulation and blood plasma level. Well, what happens when you absorb a lot of water out of your urine, or what is going to be your urine, you don't have a lot of, it's going to be very concentrated now, and you don't have a lot of solutes, and thus your urine will be very, very dark. Not very, very dark, but it'll be dark yellow. This is why when you go to the bathroom and urinate, and you look at your urine and it's dark yellow, because you're dehydrated, and you absorb the water out of that urine, and now you increase your blood regulation, your fluid levels. And you increase your fluid levels, you're not as dehydrated, and thus you raise your blood volume, your blood plasma, so you're better at exercising. So that's one mechanism. See if I missed anything. Nope. The other hormone is the aldosterone. Aldosterone is really the major one. So it has the same effect. It increases your blood volume and your fluid regulation, your fluid level, but it works through a completely different mechanism. Aldosterone, what it does is it absorbs sodium. So by absorbing sodium through osmosis, by water going to a higher solute concentration, you're absorbing all that sodium, water is going to naturally leave the collecting ducts and follow the sodium, and thus it kind of does the same thing as ADH, and you increase your fluid volume and your blood plasma level. Now, how this all works, aldosterone is it has a lot more steps than ADH. Okay, so aldosterone responds to low plasma level of sodium or a high plasma level of potassium. It does the opposite with potassium. It causes you to excrete more potassium, if you ask us that. Now, what it does is how aldosterone is, it doesn't just act on the kidneys like that. Oh, it does. Sorry. So aldosterone, what it does is aldosterone is what causes the effects. But your kidneys don't just release aldosterone when they start. And what to do is it has to go through a whole mechanism. And it does is say you have a low blood sugar. So you have a low plasma volume of blood, or you have a low volume of sodium, or you have a high volume of potassium. So your kidney will sense this, just like your posterior pituitary senses and releases ADH. Your kidneys will sense this and release a hormone or molecule called renin. Renin will go all the way to your lungs and cleave something called angiotensinogen to angiotensin 1. Angiotensin 1 will then be cleaved again to angiotensin 2 via a hormone called ACE, or angiotensin converting enzyme, to angiotensin 2. Angiotensin 2 will then go back to the kidneys. Angiotensin 2 will go back to the adrenal cortex. I believe it's adrenal cortex, not adrenal medulla. I did not say on my guide, and I forgot, but I believe it's the adrenal medulla. But it goes back and it releases aldosterone finally. And then aldosterone causes you to absorb more sodium, water follows sodium, you increase your blood plasma, your body's happy. Or you release more potassium. Now another way it works is angiotensin 2, before it releases aldosterone, is a potent vasoconstrictor. And vasoconstriction will thus constrict your blood vessels, and thus that will increase your blood pressure substantially. So angiotensin 2 increases your blood pressure. And this is this is what ACE inhibitors do. ACE inhibitors inhibit that enzyme that cleaves angiotensin 1 to angiotensin 2, so you don't have angiotensin 2, so you can't raise your blood pressure. So thus you can lower your blood pressure via ACE inhibitors. If you ask us what are ACE inhibitors, but essentially that's what you have to know. ADH increases your blood sugar. ADH increases your blood volume by absorbing more fluids in your collecting ducts in response to low blood sugar. Why do I keep saying that? Low blood plasma And aldosterone indirectly increases your blood plasma. Here, I said it right. Your blood plasma through a different mechanism. And that mechanism is you release renin in response to having a low blood plasma and having a low blood sodium or a high blood potassium. Thus, you release renin. Renin goes to your lungs. Renin is released by the kidneys. And renin goes to your lungs, releases or causes angiotensinogen, which is inactive, to become angiotensin 1. Angiotensin 1 is cleaved to angiotensin 2 and by ACE. Angiotensin 2 goes all the way to your adrenal medulla, I believe, and releases aldosterone. Aldosterone goes to your collecting ducts and causes you to absorb more sodium. You absorb water, your body's happy, and thus you increase your fluid level. 10 is confusing. Well, it's not really confusing, but he tries to confuse you. To understand how both amine and fat-soluble hormones operates to mediate physiological effects. Now, it's confusing because hormones are normally divided into two classes, steroid hormones and peptide hormones. Steroid hormones meaning testosterone, progesterone, and really anything with ogestrone, or ON at the end of it. And they're made by cholesterol. They're made out of a steroid. So they're a steroid. That's what they are. They're made out of cholesterol. And since they're a steroid, that means they're absorbed directly into the cell, so they don't need a receptor. You have a little cell, a little circle guy, and the steroid hormone comes by and it just goes right into the cell, and thus and then it causes its physiological effects by increasing protein production, mRNA synthesis. It makes more proteins by going directly into the cell, and that's steroid hormones. Steroid hormones are also called fat-soluble because they're made of fat. Steroid, cholesterol is a fat kind of, so the fat-soluble steroid hormones. Now, amine is kind of the same thing as a peptide hormone. A peptide hormone means it's not made of cholesterol, it's made of peptides or proteins. So and since proteins can't cross the cell membrane, they have to bind to a receptor on the surface of the cell instead of going directly into the cell. And they act through a second messenger. They bind to the receptor tells a G protein to activate adenylate cyclase, which is another molecule. Adenylate cyclase activates cyclic AMP, which is the second messenger. Cyclic AMP activates a protein kinase, all in the guide. No, I just said cascade. Activates a protein kinase. Protein kinase exerts whatever effect it has. So peptide hormones, which are the same thing as amine hormones, and the amine hormones are thyroxine. It's thyroxine is a peptide hormone, and amine hormone. Thyroxine and thyroid hormone by T3 and T4 are amine hormones, so they bind to receptors directly on the surface of the cell, whereas fat-soluble, which is the same thing as steroid hormones, can go right into the cell and diffuse across the plasma membrane, and the receptor is right near the nucleus. So that's what he's going to want to know. Understand GH regulation. Doesn't really talk a lot about it, but GH regulation fluctuates with time. It's not really certain. This is very confusing because he has one slide on GH regulation where he goes like this, and it spikes at one point and never explains why it spikes. And I don't know why it spikes. But then what he starts talking about is in general to every hormone, which is the action to control every hormone, which is through negative feedback mostly. Negative feedback being your body doesn't need it anymore. So if you have a high blood sugar and glucagon increases your blood sugar, if you have a high blood sugar, you're no longer going to increase your blood sugar. So glucagon is negatively told to suppress itself and stop being released. And the opposite is true. If you have a low blood sugar, you don't want to release more insulin because insulin lowers your blood sugar. So the low blood sugar negatively tells your pancreas to not release insulin. So it responds to negative feedback. Now the other thing is called upregulation, downregulation, which is kind of the same thing. If you have need for the hormone, so a good example is with, oh god, we use insulin glucose again instead of throwing another hormone into the mix, but that's actually, doesn't really work that way, but that's an example, so we just use that as an example. So if you have a lot of blood sugar, you're going to need your cells need a lot of insulin. So your cells will or express a lot more receptors for that hormone when you need a lot of it. You need it. And the same is true for downregulation. When you don't need that hormone, your body is going to repress its receptors, so it's not as effective. And I don't know if that answers the question because I really don't know what he was asking. Now for the muscle section, I didn't really, his PowerPoint was kind of horrible. It didn't explain anything about the questions he was asking, so I used my questions that straight from the graduate exercise phys class. I just copied and pasted them, and these are from the graduate class. So I'm assuming if this is the information from the graduate class, this is good enough for his class. Because graduate ex phys, this is what Dr. Panton asks, so I'm assuming he wouldn't ask more than this. Question 1, I don't really know what was on his study guide, but mine is pretty much the same thing. The different types of contractions and the types of training. So, as we know, the definition of endurance training is performing something high frequency of motor units. Now we're getting a bunch of fancy since this is the graduate class I wrote. Okay, so I'm just going to simplify it and say pretty much what I'm saying instead of using all the words. If you have the guide, you can follow the guide. It's a lot more detailed than what I'm saying right now. Okay, it seems he talked more about resistance training, so I'll skip the benefits of endurance training, what physiologically happens in your body, whereas you produce more mitochondria, more enzymes, more all that good stuff. But resistance training, okay, as we know, resistance training breaks down your muscles. You're overloading your muscles, so you fuck up your sarcomeres, and you break the actin and myosin. You break some proteins. What happens during recovery is first you increase blood flow to that region, so your muscles inflame, and your muscles actually get kind of red and get kind of pumped up because you have a lot of blood in that region of the muscle. Because blood, of course, is a transport medium. It's to recycle all that waste that you just broke down, all that chaos from breaking down the muscle, so it kind of recycles it. And that's what inflammation is. And thus, that's your body senses this as pain. And that's the soreness that you feel after exercise, if you feel sore, if you adequately broken down your muscles. And then what happens is you rebuild more glycemic enzymes. So you rebuild more well, I won't use any examples actually, but you build more glycemic enzymes, so you're better at next time responding to the anaerobic. Because when you're resistance training, you're not using aerobic respiration, you're using anaerobic glycolysis. So you build more glycemic enzymes, you build more actin and myosin, more sarcomeres, so you can do more forceful contractions because you have much more sarcomeres. And that's how your muscles actually get bigger. They don't get bigger by building more muscle fibers, you get bigger by building more actin and myosin, by increasing the cross-sectional size of the muscle. You have more sarcomeres, you can cause a more forceful contraction. Two, know the biological and morphological adaptations that result from muscle training. That's pretty much in the previous question about how your muscle responds to resistance training. What it actually is doing physiologically, you're building more enzymes, more actin and myosin. You're getting more efficient using ATP, creatine phosphase. You're just building more enzymes to respond to glycolytic glycolysis much better. Glycolytic glycolysis and aerobic glycolysis. That's referred to as myoplasticity. And you won't use that word, but myoplasticity is your muscles responding to being extremely plastic, so being able to respond to any stress, really. Don't think you talked about the two theories, but you have hypertrophy and hyperplasia. Hypertrophy is you increase the size of your muscles by increasing sarcomeres by actin and myosin. Hyperplasia is actually increasing the number of muscles you have by increasing muscle fibers. Hyperplasia does not happen in humans. I included a lot more than you were asking. Distinguish between concentric, eccentric, and isometric contractions. Concentric is your muscle shortening. Eccentric is your muscle lengthening. So the classic example is with a bicep curl. So a bicep curl, if you actually look at the muscle, it's when the muscle is contracting. So the bicep curl, you can think of it as shortening, or you can think of it as contraction. A bicep curl is when your muscle is shortening or is contracting. So your bicep head is actually contracting and getting smaller. And then when you release or go down, your is actually lengthening, and that's the eccentric. So concentric, eccentric. Can't always think of it as shortening and lengthening though, because when you're doing a squat, it's opposite. So when you're doing a squat, you can think of it as going against gravity. When you're going against gravity, that's the concentric movement. So when you're doing a squat, the concentric will be standing back up, kind of, because you're going against gravity, or you're going against a load, a force. That's it. An easy way to think about it, going against a force. Now, isometric, iso means same, metric means length. So isometric means your muscles are not really shortening or lengthening. So that would be like pushing against a wall. Obviously, you're producing a lot of force by pushing against a wall, but your muscle is not contracting or lengthening. Same thing with like squeezing something. If you're squeezing something, your muscle is not contracting or lengthening. Well, I mean it's contracting, but it's not shortening or lengthening. So that's isometric. Are there gender differences in skeletal muscle? That's kind of common sense. Men have more muscle mass than women. It's just the way it is. And that leads to, since men have more muscle mass, they can produce much more force than women. So they're maximally stronger. They have a lot more absolute strength than women. Again, that's probably going to be a question. Absolute strength. It's not relative strength. Relative means to your body. So you take a man and a woman with the same fitness level. Or let's say the woman is stronger than the man. Well, she's relatively strong compared to the man. But absolute will be like a man benching 200 pounds. A woman cannot bench, probably not be able to bench 200 pounds, so the man is absolutely stronger than the woman. But relatively, maybe he's 190 pounds, so he's not really, he's only, let's say he's 200 pounds. He's benching his body weight. So relatively, he's only benching his body weight. But the woman she's, let's say, 120 pounds of muscle, and she can bench 150 pounds. So she's relatively a lot stronger than the 200-pound dude, because she's benching more for body weight. So relatively she's stronger, but absolutely she's not. So men have much more absolute strength than women. So I can guarantee you that will be a question. They're absolutely stronger than women by absolute strength. What is periodization, progressive resistance training? I'll go into rough detail, and I'm sure most of you have the guide because like 40 people bought it. So, but periodization is a training method. So again, since your body adapts to exercise, but eventually you plateau and you stagnate and you no longer adapt because your body, you have to stress your body and release a new stress to it in order to respond to that. So what periodization is, say you have a certain period, you plateau, you decrease it by like increasing the volume, so then you increase it again by increasing the intensity. And this is mostly seen in running. Like when you're running, you have a period of like a massive volume increase, and then you decrease the volume, and then you increase the intensity. So your periodization. You have certain periods where it's like a sharp mileage, we'll call it a mileage increasing phase, but it's where we just relate to everything, a volume increasing phase. We focus on volume, and then the next period you focus on intensity. So you decrease your volume and increase your intensity. And the next period you focus on sharpening. So I don't know how that period focuses on, but you focus on sharpening. So that's why you have to have different stages. Like, oh, this is my volume phase. This is my sharpening phase. It's my peak phase. And it's normally in different cycles. I don't know how much you focus on it. Concept of specificity, we already know that. Describe DOMS in terms of structural and biochemical changes. Well, we kind of talked about that. DOMS is when it's a delayed onset muscle soreness. So after you've done exercise and your muscles get sore, that's DOMS. That is caused by increased blood flow to the muscles. So you increase the inflammation. And increasing your blood flow, and your body senses this as pain. And we kind of went over pretty much what's happening. You're tearing the Z-disc, you're tearing the sarcomeres, you're tearing the actin and myosin. You're pretty much tearing your muscle down, and thus your muscle has to repair, and thus you increase the blood flow to that muscle, and your brain perceives that as pain. And that's actually a protective mechanism, because when you have pain in a muscle, you don't want to work it out anymore. And that's good because your body is actually recovering when you have pain in that area. Of course, it's a certain kind of pain. You don't want sharp pain, like bone pain, or like a torn ligament pain. But in general, after you worked out and your muscles are sore, it's because your muscles are recovering. And your body is making your muscles sore so you don't work out more, so it has time to recover. And I talk a lot more about DOMs. Getting copy and paste from my graduate guide, I mentioned a lot of enzymes. Know the effects affecting the force of muscle contraction. Is that the last one? Yeah, it's the last question. Okay, so the effects of force. Again, all he asked was force velocity. More velocity so you contract harder. I went into a lot more detail, so I really don't know what's to focus. Okay, I'll focus on the last part. The velocity of contraction also affects the force production. My common sense, if you have a lot more velocity, you produce a lot more force. I think the only point he wants to know about that is in a high velocity of contraction, concentric force actually decreases and eccentric force decreases. Muscles with fast twitch muscle fibers produce much more force because they're fast twitch muscle fibers. So with increasing velocity, the force production of concentric contraction will always decrease. Blah, blah, blah. I really don't know what he's asking because his slides really sucked. But I included as my graduate guide. I'm sure most of you have the guide. Like, again, 40 people bought it, so it's like half the class, I think. But that's pretty much all the questions. And then at the end of my guide, I included a few questions that maybe I would ask if I was a professor, like what causes the most increase of VO2 with training? That's cardiac output. Because your cardiac output is what causes your VO2 to increase the most. And what increases your cardiac output? Stroke volume. So stroke volume will be the answer to what increases your VO2 the most. How do you know max VO2 is reached? Again, that is someone passes out. If they pass out, they've reached the max VO2 most likely. If their VO2 is no longer increasing with exercise, or or heart rate is plus or 10 minus beats per minute, or they've reached 8 to 10 millimoles of lactic acid. If they just voluntarily stop, they do not reach their true VO2. They reach mostly the VO2 peak. So that's pretty much his study guide and the questions I answered. Fortunately, the next test I think the next test this test is pretty easy actually, I think. The third test, because it's all aerobic respiration, aerobic capacity and whatnot. The fourth test is really easy because it's simple concepts. The fourth test is on atherosclerosis and exercise testing, like underwater weighing, all that good stuff. So it's pretty simple concepts. There's nothing they can really throw at you. This test I also believe is simple, minus the endocrine response. Focus on the endocrine response to exercise. Some very important key steps and tips to know is know what Vo2 max is, first off. What causes the greatest increase in Vo2 max? Stroke volume, by increasing your venous return, and causes the greatest increase in Vo2 max. What is the best thing to focus on for aerobic exercise? Intensity is a lot more important than anything else. The endocrine response just understands things like what cortisol does, what epinephrine do, what they cause. They cause you to increase your blood glucose through gluconeogenesis, glycogenolysis. Understand how muscles adapt to exercise by breaking down the muscle, literally, by breaking it down, and then it builds up stronger. By increasing certain proteins, certain enzymes, by increasing actinomycin, by hypertrophy, essentially. It gets bigger, increases its surface area, so it can contract much better. Definitely know the differences between men and women. Men have always have a higher VO2 because they have more muscle, they have more hemoglobin. It's just a fact of life. The more muscle you have, the higher your VO2 is going to be. Know that in strength training exercises, men are stronger than women in absolute strength. Not in relative strength necessarily, because relative is relative to you. So again, back to that bench press example, if a woman can bench press, she's 120 pounds, she can bench press 150 pounds, she's relatively benching much more than a guy who can only bench his body weight, because she's benching her body weight plus 30 pounds, even though she's benching less absolutely. But males have more absolute strength than women. I think that's about it. So again, a few tips I think he'll ask I went over, and I went over pretty much every question on his study guide. Just keep reviewing his PowerPoints, watch the video, read my guide, whatever, ask questions on Facebook, I'll answer them, etc. Any questions you have, answer them, ask them, I'll answer them as best as possible. Good luck on your test.